Hello everyone. Today we will be learning how to connect Python with database. So the first thing you'll need to do is you'll need to install a server which will be able to run the SQL commands in the backend. So for that I have used MySQL server. You can just go to the first link and download it from here, the first option. Then after that I have also downloaded MySQL workbench. This MySQL workbench will allow us to create a connection which will give us the host username password which we can later use to connect it with the database. If I open MySQL workbench, you can see that I have already created a connection with username root. I have set my own password and the host is this IP address. If you want to create another connection, just click on this plus and create connection. After that, I've used Python notebook. I've used a Jupyter notebook to execute all the queries that I want to. As I'm using MySQL, you will have to install the package MySQL connector Python. This will allow you to connect the Python with your database. I have already installed it. You can use pip install command just to install the package. So first thing we'll be doing is we will import the connector. We have to first create a connection with the server, then create a cursor object, then we can execute any query that we want to. So as I showed you, the host is 127.0.0.1 as you can see in the workbench. Username is root, password is what I had set for my SQL database. So we create a cursor. Cursor will just traverse through your entire tuples and it will give you the output. First command we are going to do is creating a database. To store all tables and all, you will need a database. Create database command is available in MySQL. This will directly create a database with the name dbms. I have already executed these codes, so I'll create another database. Let's say dbms1 and execute. Database is created successfully. It is crucial that after executing whatever queries, you should close the cursor and connections. So let's just create all tables entities. So again, we do the same thing. We import the header files. We'll create a connection, and if the connection is connected, if it is connected, output of is connected will be 1. We create a cursor object and execute. Cursor.execute will execute the queries that you will give it, and cursor.fetchAll will fetch all the rows. It will fetch all the tuples that are the output of the query. So here we are creating a table course. Course ID is having a data type integer and it is the primary key of the table. Then course title, department, credit hours, descriptions are also present. Another table we are creating is student. Student ID as primary key and other descriptor attributes. Same with professor. Professor ID is the primary key and others are descriptive. What we can do is we can create it for different all entities and all relationships. We can create different tables. But another convenient thing that will reduce the number of tables is just adding foreign keys to the tables. Just like section table, you just add foreign keys instead of merging all primary keys and creating a table only for foreign keys. So in section table, each section has a given course in a given semester which a single professor is teaching. So these foreign keys are referencing those tables, each of which have their primary keys. Let me just execute this command and we have an error. Uh, Table course already. Oh yeah, I created a new database. I just forgot to change the name. DBMS1 and tables are created successfully. These commands are used just create table basic commands. And after that, let's do some DML commands. We want to insert values into each table. The syntax is insert into table values. Simple. Again, we create a connection with the server. Let me just change the name of database. Create create a cursor object and execute the queries. We are adding values into each query, into each tables. Let me just execute this. Data is inserted successfully. In the end, we are just committing the transaction. As there are no errors, it won't need to roll back. It will commit through. It will go through the entire thing. If there is an error, we have done some exceptional handling. It will say failed to insert data or whatever that we can create on our own. Now to find the average number of students registered per section. The basics are the same. Just create a connection. Using that connection, create a cursor. A cursor dot execute, and just the rows are cursor dot fetch all. You fetch all the results you want, and then you print in your desired format. So Python database connectivity is used because like each executing in file systems in Python and using databases each have their advantages. Python is quite useful to do arithmetic operations, mathematical operations, which database is not so good at. So to have best of both the worlds, we just use Python database connectivity. So we can connect database with Python and perform all the arithmetic operations that we want to. So that will make our lives easier. Okay, so we want to find the average number of students registered per section. We will just select the rows, select the columns that we want, and then we will just perform a join operation in which we'll just get count from the registration, because we have a table registration which maps all students which have registered. Just execute this query. So as you can see, chemistry, average number of students is just like the total number of students registered in a given course, same as count of students in a course. So as you can see here, student table, there are 5 students with the student ID 26, 27, 28, 29, 30. So in registration table, you can see at 26, 27, 28, 29, 30, 26, 27, 28, 29, 30. For different for different courses, each student has registered for 2 courses, and you can see here these courses have 222 selected. Now if we want to find all courses taught by a specific professor in a specific semester, so we just want the course we want to find the course that's taught by a specific professor. So we just need the course title. So inside from the table course, we just select c dot title, and we will need the course table, professor table, and semester, because in each semester there's a section where a professor is teaching. So specific semester, in this case we've just taken fall, and we've taken the name of the professor, Dr. Jones, in the year 2023. So if we execute this query, you can see courses taught by Dr. Jones in fall 2023 is mathematics. Let me just check if it is recording. Yeah, recording. Okay, we'll use some date functions. List all sections offered in spring 2023. Again, follow basic procedure. After that, we want to find all sections that are offered in spring. So we will need what's that? Uh, so we will need the semester table and all sections. So we will also need sections and we will need course table because we have to list all sections. Okay, so as you can see, we select the section ID, we need section details, and course we are just so that we show which course is selected. We just want the course title and the year and season, sem season you could say, or just sem name. It's like spring, fall, winter, summer. So we just join these courses. We can also use natural join. If we use natural join, we omit this part. But as we're using join, that's fine. We just join section with course. As there is s dot course ID, both have course IDs. It will be joined on that. All the rows, all the tuples which have both course ID same will be selected. Do the same with semester. This will just create, it will just merge all the three tables with the common values. Where semester dot year is equal to 2023 and the season is spring. Yeah, so as you can see, sections offered in spring 2023, section ID 32, chemistry. Chemistry is offered in spring of 2023. Now, if we want to update a student's major, we do the same thing. After each, ensure you commit. It's a good practice just to create transaction because if anything happens, that if any fault occurs that you will have to roll back, it is good. As you know, after you have committed, it will go back to that point only. If you don't say I don't commit over here and there's some error ahead, then it will roll back and you will have to do all what if you will lose whatever progress you've done over here. So instead of that, if you commit here and if anything happens here, it will roll back to the last commit. So you won't lose any major progress or anything that you have done. So we want to update a student's major. So simply we'll just use the update command, update table name, set major equal to whatever we want. In this case, we've taken as computer science where student underscore ID is equal to 27. Hmm. Student ID equal to 27. As you can see in the student table, 27. Olivia Parker, physics, third. So if we execute this command, as you can see, her major was, I forgot, Olivia Parker, physics. So let me just student's major updated successfully. So let me just create another. If we want, actually, I don't need to create another. I will just create. Actually, let me just create another. It will be easier. I will just copy the same code just to see if it has updated. Okay, I will just do select select star from student. Let me just comment out this line as it is not necessary. Then I will just create results is equal to cursor dot fetch all. I think that should be good. Result is equal to cursor dot fetch all. And let me just print the results. If I do this name cursor cursor. Yeah, here you can see Olivia Parker. Her is changed to computer science. Previously, it was Olivia Parker's was physics. Her major was physics. Now it is changed Now it is changed to computer science. Okay, so our query is working. We don't need this anymore. Okay, we want to list all students registered for a specific course. All students, so student table will be needed. Specific course will be needed. All courses occur in a particular section, so section will also be needed. We need the professor's name also. So we will also need professor's table, all students that are registered. So we can use registration table also. So first we'll just join all these. We will just join all these. For the specific course, we'll just select student's first name, student's last name, and professor's name. Then after we join all the four tables, we'll just select, let's say, mathematics. So where c dot title is equal to mathematics, it will just, if I just execute this, it will show Olivia Parker and her professors. Hmm. For mathematics, student registered for mathematics and their professor. We can try something else also in this. Student registered for mathematics and professor. Let's see something else. If I want to change those values. Okay. Hmm. What? Let's say chemistry. 2621. Is it available in this? Let's try chemistry and see if we get Noah. Let's see if it is there. Hmm, let's change to chemistry. Yeah, as you can see, we have two students actually. I saw one, Noah Turner. Uh, well, actually, we can just change this to chemistry as well as we are chemistry. Noah Turner and Dr. Turner. So this is also working properly. We just changed it to chemistry and we have Noah. Yes. Okay, if we want to delete a specific record, we just use delete from table name. But that will just delete all the rows that are present. So what we do is just add a where clause so that we delete from us for a specific student, specific section. So registration table has all these as you can see over here. Yeah, registration table, student registration ID, student ID, and section ID. Hmm, okay. Hmm. Yeah, actually, in the previous one, I just noticed one more thing. When let me just go back. So when it was mathematics, right? We got Olivia Parker, but we had changed Olivia Parker's to computer science. Thing was, I had two different databases. So now, if you do this, you will get a change. Probably not. Yeah. Database names have to be changed. But let's stick with chemistry on this part. Cool. Chemistry. We got some other student, William Jones. Hmm. History. Should get Noah Turner and James Turner in the new database. Yes. Yes. New database. And again, let me just change this name because I already created stuff in other database. Yeah, so we select from table registration number, particular student ID and section ID. By row record successfully deleted. Okay, we have to find courses that student has not yet registered for. Hmm. Okay, so these queries, it's fine if we do it on either database. But the only thing you can't execute again is these. Our first command was to create a database. If you create a database with the same database name, if you execute this twice, it will throw an error because database name already exists. Let's see. Yeah, because database can't create DBMS one, database exists. Same with the create table command. Once tables are created, you can't create it again. So again, this will pop up an error if I run it again. So these commands not to run again, but others you can. Same with insert commands. You can't run insert because it will violate the primary key calls. Primary key, see, it will say fail to insert data, duplicate entry for 26. Just the first one. It's with student ID 26. It's duplicate, so you can't. But these ones you can always execute twice. These will work. Yeah, we changed from compute. We changed Olivia's major from mathematics to computer science. So hers reduced by one. It was two before. Okay, let's go back. We deleted the record. Student that has not find all courses a student has not yet registered for. Okay, so we'll just select it. We need all courses, so we need the title of the course. Then we need, let's say, student with student ID 123. We just join the section and registration tables because those are the foreign key of student ID. Sorry, not student ID, section ID, because we want to find where. So what do? Is we just select the title where course ID is not in. So all the courses that are not in the or not in the course IDs that the student 123 has registered for. So if I just execute this, chemistry, physics, mathematics, biology, history. So this student has not registered for these courses. Hmm. Okay. Last query. Count the number of students registered. Simple. We just have to count the number of students. Actually, we are using distinct from registration table because student IDs, one student may have registered for more than one course. So we use distinct to get the distinct number of students that have registered. And if we execute this, we see number of students five registered are five. In the beginning there was six, but we had where did I go? Yeah, we had deleted a registration record for a specific student. We had deleted this one, a student ID 28. So initially there were six, but now there are five. And in the end, I just created a reset command that will just delete all entries from all the table. So if you just do this, all contents, all tables are deleted. If you run any, it won't give any output. If you run this one, it will just remove two. This is, should have mentioned the database name, but that's fine. Reset DBMS1. So all from DBMS1 are deleted. Now any that I execute, the DBMS1 here also, if I execute this, student registered for chemistry, none. Then you can go back, insert all commands, insert queries, everything you can do. Well, that's it for today. If you have any doubts, you can ask me anytime. Stop recording. Recording will be saved.